Peggy 18.
That's supposed to happen?
Dunno.
My friends are bouncing off the walls 'cause their weekend seemed impossible. So we need to meet up and start the show. No, we can't slow down. It's time to go. Can we start it up? People jumping off the roof, say hey. Start it up loud. There's hearts sinking if you say hey. Start it up loud. So sing it in the streets, say hey. Start it up loud. 100 dancing feet, say hey. Start it up loud.
It was a good day. Oh, what a good day. But it is long gone now. When all the stars fell down. It was a good day. Oh, what a good day. That day you broke my heart. I loved you way too hard. Now I'm free.
Hi, good afternoon. I'm Stephanie Falk, Software Engineering Manager at PlayStation and part of the communities team.
Hi, I'm Swati Samanchi. I'm the Senior Manager for DevOps.
And I'm Amy Che, Senior Solutions Delivery Manager for the Sony teams located within the US and working at AWS. So we know that it's fairly late in the afternoon. How many of you are waiting to go to happy hour after this? So we appreciate having you here. We know that you're probably here because you're considering going multi-region in your architecture if you aren't already using multi-region architecture. Your reasons might be numerous for using multi-region architecture. Maybe you're considering lowering the latency within your systems. Maybe you're thinking about data regulations. Maybe you just heard about multi-region and you thought that it was the right thing to do. Whatever your reasons, we're here today to help you go multi-region. At the end of this session, we want you to be able to apply some of the best practices of implementing the multi-region architecture so that you can continue to scale out your business. We're going to cover some fundamental questions regarding whether or not you need and want to go multi-region. And what are the building blocks for going multi-region? Sony PlayStation will be covering those same questions as they went on their journey to using the multi-region architecture. So to answer the first question of whether or not you actually need multi-region, you probably want to know what multi-region means to AWS. And the answer is, we want to provide the building blocks for your company's definition of multi-region. At Amazon, we start with the customers first, and we work backwards. We provide a global network with 44 availability zones distributed across 16 regions, and we're still scaling out. This enables you to build your architecture to meet your customers' needs wherever they're located globally. And then we provide you the building blocks that you need to build the multi-region architecture. Do you need to go multi-region? Generally, the answers that comes out to this comes from 3 various buckets. They fall into wanting to lower latency to a subset of customers. These are ideal for customers who have applications that allow for eventual consistency, or applications that can be operated separately, like online stores or delivering dynamic content. Or perhaps some of you in this room are concerned about legal and regulatory compliance. Data sovereignty is a hot topic. Some of you might even be working on the EU's General Data Protection Regulation, or the GDPR, which is due in May 2018. But the largest bucket for the reasons for going multi-region is for the business continuity and disaster recovery planning. You want to ensure that you keep all the essential aspects of a business functioning despite a disruptive event that occurs. You understand that having a degraded performance is better than a system failure. So we know that stuff breaks all the time, but rarely in multiple places at the same time. Resiliency is critical to the quality of service to your end users, but it's also complex. Like security, it can't be bolt on at the end like an afterthought. It has to be built into your architecture. It has to be an end-to-end discipline. It's also a key cost driver. How many sites do you need? How many regions? How many copies of the data? Do you need to upgrade your applications? Do you have to consider training other personnel? These are all investments you have to make into your systems and into your people as you're scaling out your architecture. Resiliency in the cloud doesn't have to be like traditional IT, but you do want to meet the business objectives that you have for traditional IT in meeting the availability and the recovery times. There are better ways to provide continuity in the cloud, so you should use them. When you're discussing business continuity, you might hear a lot of acronyms. Mean time to recovery, mean time between failure, recovery time objective, recovery point objectives. You might have heard of these metrics, or maybe this is the first time that you've heard of them and you're seeing them. And we're not really here to talk about the metrics around them. You're here to hear about multi-region architecture. So in a nutshell, what those acronyms mean is that you're talking about the trade-offs that your businesses can afford between the data loss and the sliding scale to the recovery time from an outage. As you weigh out these different areas, you're going to optimize on one, and the other one will degrade a little bit. And so the conversation that you should be having with your teams is where on the scale you want to be, the data loss to the downtime. And the answer to this question is different for every single business. And so it's always important to have these discussions to understand the trade-offs and the cost to implement around them. Do you want to go multi-region? And it's a question you really want to ask yourself, even if you're deciding that you need to go multi-region, because there are still challenges around going multi-region. If you're trying to solve latency issues by going multi-region, you need to understand, even with the best engineering that we have today, we still haven't solved the physics problem of taking bits from one region, transferring it over fiber optics to another region. There will always be some inherent latency when you're sending data from one place to another. So that's something you want to consider as you build out your multi-region discussions. You might have defects swept under the rug that you may or may not be aware of. I don't know about you, but sometimes when I'm on a website or I'm using an application and something goes wrong and I get frustrated, or something annoys me, but it doesn't annoy me enough to call or log a complaint, or send in a defect request, or send in that trouble ticket with the ops team. Or you might have an issue that your development team or your ops team have that you're not aware of. They may have been staying up into the middle of the night trying to meet that deadline, and they hacked together some spaghetti code and they didn't tell you about it. Or maybe you're aware of it and your teams didn't think it was that important. When you scale out your architecture, you might potentially be scaling out the problems that you hid under the rug. So you probably want to pick up that rug, look underneath, and clean it out a little bit. And finally, most customers aren't actually testing for catastrophic failure modes. Or if they are, they're not testing for them appropriately. It's difficult to go through a disaster recovery test. You have to get the resources, you have to set aside the time, and it impacts your development time and your business time. It's another investment that you need to make. And you have to have well-established run books when you're going through these scenarios. If you haven't proven it out for a multi-availability zone scenario, it's going to become even more complicated when you're building it out for multi-region. If you haven't tested it properly and you haven't taken these three things into consideration, going to a multi-region architecture or having an active disaster recovery is more likely to cause downtime than provide the resiliency that you're looking for. At AWS, we talk about having 4 different strategies for disaster recovery. At the coldest end of the scale, we have the backup in the store where most traditional IT companies are aware of. You take your data, you store it on a tape, you put it in another location. When something happens, you have to call someone, get them to turn that server back on, warm up the systems, bring up the data, and it may or may not be in sync with whatever you had last. You move a little bit warmer and you have the pilot light, that gas light that you keep up just a little bit. And this is where you've identified those business critical core elements of your systems that you want to always keep running in the cloud and potentially in another region. This way, you always have something going. So if there's another failure going on, another catastrophe, a disaster, you have your business critical core elements running, and you can quickly scale it up to production mode within a matter of minutes. After that, you have the warm standby. This is a scaled-down version of your production environment. It is running your business-critical applications in another region somewhere. And you are running your dev and test environment and probably asynchronously copying your data between the different regions. And so when the disaster comes, it's even faster to deploy and scale up to production. And finally, most of you are probably wanting to talk about is the multi-site, multi-region action, where you have the active scenario. You have a full replication of your architecture between multiple sites. You're simultaneously synchronizing your data between the regions and load balancing your applications across the various regions that you have. So if you've determined that you need multi-region architecture, or that you possibly need it in a few years, maybe 2019, and you're willing to accept the complexity and the cost for going multi-region, then here are some of the building blocks that AWS provides for the multi-region architecture. You always want to consider your full stack when you're talking about your architecture. So at AWS, we start with your VPC. You have your regions, obviously, since we're talking about multi-region, and you want to follow the best practice of having multiple AZs within each region. Connect all of your AZs and your regions using a scalable DNS, Route 53, and connect the network using Direct Connect and CloudFront. At your compute layer, you have your AMIs and your containers that can be copied across the regions. In your data layer, you can have your S3 objects, your databases like RDS, DynamoDB, Redshift, all have cross-region replication. Ensure load balancing across at the access layer with your classic load balancers, your elastic load balancers, your network, your applications, because you want to ensure that all your regions are performing optimally. And with your regions, you have to consider the fact that your monitoring and your logging will change. So you also want to utilize your CloudWatch for the logging and use CloudFormations to deploy your various scenarios across in a uniform fashion. Make sure that your components are loosely coupled as you examine your architectural stack. One of the many challenges we face as architects and developers or managers is that you want to make sure your applications are distributed. We are tasked to address the scalability, the fault tolerance, and the high availability of our applications. How do you accomplish loose coupling? You want to build independent components, and you want to decouple the interactions. Use common interfaces or common APIs or open source to connect your components together. And use messaging in your architectural patterns. Messaging enables decoupling. It's reliable, it's durable, and fault-tolerant delivery of messages, which enables the focus on logical decomposition of your systems and increases the autonomy of the components. At AWS, we provide a couple services around messaging. Amazon Simple Notification Services, or SNS. It's reliable. All your messages are stored redundantly across multiple servers and data centers. It's scalable. Applications can publish an unlimited number of messages at any time, and it's simple. In most cases, you can get started with SNS using just 3 APIs: create topic, subscribe, and publish. The other main messaging component we have is Amazon Simple Queuing Service, or SQS. Like SNS, it's redundant across multiple AZs in each region. And there are multiple copies of each of the messages stored across the multiple AZs. And the messages are stored up to 14 days. Due to the distributed architecture, SQS scales without any pre-provisioning, which means it scales up or scales down on demand without you having to constantly monitor it. And it also helps you maintain the cost of the performance. So now what? All of this sounds great. You've had those discussions. You need multi-region architecture. You did your homework. You had those difficult discussions around all the acronym soups, and you want multi-region architecture. You understand the building blocks. Now you want to dig deeper, and you want to go and build the multi-region architecture. Swati and Stephanie will walk you through Sony PlayStation's journey to the multi-region architecture and how they answered their questions on the way in their journey. So, Swati, let's get started.
Thank you, Amy. And good afternoon, everyone. Before we get started with talking about our multi-region journey, let me just give it a little bit information on who we are and what we do, what services do we support. So we are a platform and services team in San Francisco, and we support 80+ applications, microservices across PlayStation. So some of the highlight services that I have here are what's new when you log on to your console, your store catalog, cart checkout, your multiplayer, and finally your communities, which is one of the main topics we are going to talk about today. So we began this journey of being multi-region with all our microservices almost an year and a half ago. And the reason why we are talking about communities this time is this is one of the complex services that we had, which we successfully made it multi-region a month and a half ago. So that's the reason why we are talking about this. We still have a lot of services that we talked about in our last talks on how we made that possible. So a year and a half ago, this is where we began. So as Amy said, that you first have to make the decision, do you really have to be multi-region or not? So the answer was yes, we want to be multi-region. And the next steps were, what does it mean multi-region to us? So you cannot have a blanket statement of 100% of all applications are going to fall into this category, but at least for your 80% of your use cases, we wanted to make sure we have a definition on what does multi-region mean to us. So from our perspective, we wanted to make sure that when we say the application is on multiple regions, that means we should be able to handle our instance failures, any of our zone failures, even multiple zone failures, and also our region failures. So what it means to us is we should be able to route the users first and diagnose the issue later. So with this definition comes a lot of questions, how-to questions when you say this is what we want to define for every single application, is how are you going to make sure your architecture, infrastructure for your architecture is supporting multiple regions? How are you going to make sure every application that you want to pick and want to be multi-region, how are you going to make sure you have architected in a certain way where it is in not just 2 regions, but you are scaling up to more than 2 to 3 regions as you go along. And test out a new region application performance. So our applications are running on single region for 5+ years. So it does have a good performance. Now you have to ensure when you're going to multiple regions, how are you going to make sure the performance is the same? How are you going to make sure you're able to load test on the new region before you route any traffic? And how are you going to finally enable your multi-region without no downtime? So we cannot ask our customers that, hey, we're going to be down for 2 hours and come back up again after we are multi-region for our application. It's not going to work for us, right? So for those reasons, throughout this presentation, we are going to walk through each and every question, and we're going to make sure that we answer the questions and share the experience and also the failures and successes with you guys so that you can take home some of the lessons learned. So the first thing, how are you going to architect your infrastructure for multi-region? So you already have a single region that you have your infrastructure set up. But think about if you have set it up 5 years ago, how much of a tech debt that you have and how much you have thought through. Now you have so much more experience when you are getting started, right? So you want to talk about what is that puzzle that I want to solve for my infrastructure. So that comes under the scope of infrastructure as service. So you want to define what falls into that category before you even pick a tool. So picking the tool or picking a third party or you want to do in-house is a later on question. But the first thing is, what is the scope that falls into this category so that you can automate your infrastructure? So from our perspective, it was our new accounts, our VPCs, our subnets, load balancers, our security groups, and any security policies that PlayStation has were part of our infrastructure. And we wanted to abstract that infrastructure, and then later on, we wanted to make sure that we pick a tool which actually helps us out to also track version control and also make sure that we can go back a version. So now, with this information, you can either pick Terraform to do this, or you can go with managed services if you don't have people to support those versions. So once you have built your infrastructure layer, so the next question that we went through and tried to answer was, how are we going to route these users? How are we going to route live users? So as you know, PlayStation has 60 million users, active users, right? And you want to make sure not even one user should have any issues when we are doing this transition. So the first thing first was user affinity. We wanted to make sure when we are sending the user to a particular region, the user has that sticky session. Once the session expires, we don't want user to go bounce back and forth, right? So we wanted to make sure that the user has a particular region that is assigned to him, unless there is a disaster. The second thing is minimize downtime. So whatever we want to pick, the main thing was we should be able to route users to a healthy region in seconds, in less than 2 seconds. That's basically what our goal was. And not all the applications falls into this category where you can just say, yeah, I'm just going to move the traffic and things will just work out, right? Some of the applications are heavily cached. So with that comes your percentage-based routing. So if your application is not part of your 80% use case, if it is that 20% which needs extra rules, your tools should be able to do that. So you should be able to just route 10% at a time so that you're able to warm up that cache on another region before you're successfully on 2 regions or 3 regions. And test before you go live. So whichever tool you're using, the main thing is you should be able to have a staging environment where you're able to test and confirm that, yes, I'm able to hit that application and I don't have any issues. Finally, from a multi-region routing rules, along with host name-based routing, we also had to consider path-based routing because of our microservices. So because we made sure that the services are independent to itself. So from a routing perspective, whatever tool we wanted to pick was that. So either you go with, again, you go with Route 53 or you go with GTM. It depends, the scope of the routing is the main thing for you to pick that tool. So once we had the routing in place, the next thing we moved on was we need to make sure we have our monitoring and logging set up on another region before any of our applications can start testing their apps. So the region, we made sure that we have region-specific monitoring and logging where you can just keep it local and you can make sure that it's on each region. And in case of failures, we also wanted to send the data over to another region. If there is a problem with your login, you at least have that replication going on. The monitoring tools that are connecting, like your visualization layer, was something we wanted to keep it on one region and also keep it together. So even if you have 2 to 3 regions, your visualization tool is pretty much on the same region. And finally, make sure you're not monitoring your pipeline using the same monitoring tools that you have today. In that way, you will never get any alerts because your monitoring tool is down and you're monitoring with the same tools that you have. So with the baseline of building this whole block together, now once we had all these things in 3 to 4 months defined and actually we were ready for the applications to come in and start doing the experiment, start actually testing out their application and start to see if we need anything more for an application to go live. And with that, I would like to call in Stephanie to talk about communities in specific.
Thank you, Swati. So what is Communities Group on PlayStation? Is a way for our users to self-organize around their common interest. It's a place for them to connect with each other, share content, and play games together. It was launched about 2 years ago, and today we have millions of communities on our network today and thousands of users using this feature every minute. So let's take a quick look on how a typical community would look like on a PS4 console. Most of our users like to create communities around their favorite game. They can customize their profile with a profile picture or background picture. They can join ongoing game sessions or parties or watch a live game broadcast from other members of the communities. They can also talk to other members of a community. They can trash talk, they can share screenshots, they can also share their favorite wallpaper from their favorite game. Or they can schedule gameplay ahead of time. Maybe they need some help with the big boss battle. Or maybe they want to do a raid in Destiny 2 this weekend. These are all the things that you can do in communities on PlayStation. And each of these feature segments are powered by a number of microservices behind the scene. So when we talk about multi-region for communities, we know that we have a lot of support from AWS already. We have the foundation from infrastructure. We know we can do logging properly. We can monitor. We can route traffic properly. So is it as easy as just replicate our technical stack and just deploy in a new region and voila? It's usually not that simple, and we actually took a step back and asked ourselves some questions to start. Does our data need to be in sync in all regions? For communities, our answer is yes. As a community user or a community owner, if I made an update to my community, I want everyone in the world to see it, not just the user in my particular region. And how soon should they see this change? From a user's perspective, of course, ideally real time, like right now. When I make a change in my community, I don't want to wait 5 minutes or 10 minutes for other people to see it. I want to join the parties right away. I want to watch that broadcast. So now that we know we need our data to be in sync across all regions, the next question is, does our entire technical stack already support this? Is everything ready to go multi-region? And then after that, how do you perform a seamless rollout when you go from a single to multiple regions? So let's dive right into our technical stack. These are the 4 major technology components that we use in Communities Group. Some of these we know are multi-region ready, not just because the documentation tells us that they do. It's because it's been tested and validated by some of our other microservices on the network. We know it works. That would be Couchbase and Cassandra. And then for some other technology, the document does say it supports multi-region in their latest version. And they could also be supporting passive-active setup. However, we haven't really tested it in our network. That would be the case for Solar Cloud and Zookeeper. And finally, in communities, we also use AWS ElastiCache Redis. We use it for both caching and some persistent storage as well. And we know that it does not have a multi-region ready solution. So this is really our first and biggest challenge. Our database layer just is not entirely ready. So we're going to be focusing on this in the next few slides. So when one of your technology components does not support multi-region, you really only have 2 options. One is create your own homegrown solution, which of course comes with its own baggage. The second option is to migrate, and basically migrating your data from one technology to another that is already supporting multi-region. So in order to make that decision, we want to look at how our microservices are actually interacting with all these components. Looks simple enough. Everything interacts with everything. So that was a dilemma. There's no obvious answer to this. Either way we go, it's going to be a lot of work and a lot of refactoring. So after a very healthy amount of debate among engineers and many, many meetings, and also design meetings with our VPs and directors, we decided to consolidate our technical stack. We decided to migrate all of our data out of Redis and into Couchbase. There are a few reasons for this. Like I said, it's going to be a lot of work either way, so the amount of work was really not a factor for our consideration. But by removing one of the database cluster, we have a lot less operational overhead. It's one less thing we have to monitor and operate and keep it running at all times. Cost savings. That's a huge one. That's a huge win for us. Storing more data in Couchbase costs a lot less than keeping the entire Redis cluster. And also, this is also a great opportunity for us to pay some technical debt. By removing our entire database technology, we were able to clean up a lot of our code, removing a lot of DAOs, removing a lot of libraries and dependency at the same time. So now that we know we have to migrate data on production, how? This is, you're basically trying to sneak on a train, going full speed, and hoping nobody would notice you. We don't want to have any service impact to our user, at least minimal impact. Usually, data migration is a multiple-step process. You're going to be routing a lot of read-write traffic. You're going to have to react very quickly. And it's critical that you can make changes very quickly between each step. So we start looking at what we already have today that might be able to support this in our technical stack. Feature switches. Everyone has it, right? We want to be able to very quickly turn on and off features, maybe for A/B testing, or maybe, oh, there's a bug with this really risky feature. We want to turn it off right away. In our case, our most simplest form of feature switches are a file-based configuration. Usually it involves someone maybe go on the box manually updating a property file if it's a really critical bug, or you want to deploy a new artifact with a new change, but usually require either a deployment or server restart. So this is not really fast enough in a data migration scenario. So we're looking for a way to augment our feature switch, and we found Netflix Archaea's library to be super helpful in this situation. Archaea supports many sources of configuration. It can be a database call, it can be a REST API call, or it could just be a file. And in our case, because we already have a simple file-based configuration system, it was very easy for us to plug S3 bucket right in the middle. Every time we want to make a feature switch, we would just upload a new file onto the S3 bucket. And our service would grab all of the instances of our service will be able to update this property in near real time. So let's run through our migration step with the help of these switches, step by step. So step one, we're going to run the migration process in the background. You're moving data from one database to another. You're probably transforming your data as well. And notice that we're writing our live updates to both the old and the new technology here. And you're continuing to serve your live traffic from the old stack. So at this point, it should not have any service impact to the user because you're still reading and writing to your old stack. And in addition, you're also moving some data and writing some new data to your new stack at the same time. And step two, once your migration process is complete, you want to test and validate your data on your new database as much as you can in the background. This is really the best time for you to verify your data from the database because the user is not seeing anything yet. You have a lot of time, or as much time as you need to fix any problem that you found, maybe some data inconsistency. And we're still serving our traffic from the old stack at this point. So there should not be, again, no user impact. And once you're really confident with your testing in your database, let's try switching your live service to read from the new stack. So notice that we have turned off the reading from your old database, and now you're reading from the new database entirely. At this point, you should run even more testing because now you're live. Hopefully, you have some sort of automation test suite that you can run from your service point of view. And you absolutely do not want to stop dual writing in this process because that is your fallback strategy. Once you stop writing, there's no going back. And once you're truly, truly ready, you can stop writing to your old stack altogether. Now you should be good to go. You're actually migrated all your data, and you're serving your data in your new technology stack. And you would also be able to decommission your old stack and save a lot of money at the same time. So here are some lessons learned that we have with this task. When you're making a lot of temporary or intermediate step changes, it's much better to do it with feature switches over code change. But to do it dynamically at runtime without any server restart is even better because in this data migration scenario, reaction time is critical. You don't want to wait for server restart or redeployment. And if you're using this dual write technique, I can't stress this enough. Do not stop writing to your old stack until you're 100% sure. Because once you stop writing, there's no going back. That is the point of no return. And when you're 100% sure, still wait an extra week before you decommission that cluster. Now that we have tackled the database layer challenge, let's move on to community search. You can discover communities that you want to join by searching for them specifically, maybe a game titles or preferred language or preferred time zone. And I'm going to invite Swati back up here to talk about our Solar Cloud replication strategy.
Ooh, the vendor having the documentation, right, to do the replication. So before we even get into Solar Cloud replication, we again wanted to see, do we really need search to be on multiple regions? Yes, the answer is yes. We want to make sure the user is able to search the same consistent data regardless of which region he's part of. And do we even need to be active-active, or is active standby okay? The reason there is active standby is because Solar Cloud documentation says they support active standby. So the answer is we are okay as long as the reads are active-active. Your writes, your updates, your adds, deletes, everything can be served from one region, which was fine with us, as long as we can recover if there is any issue in 10 to 15 minutes for our writes. And finally, will we have any user impact if one region goes down? If the user is able to read from any region, there is no problem. We can totally use that. So let's just jump right into what is out of box that was provided given that based on the documentation. So your primary Solar Cloud data center will be handling your writes. Your secondary is going to do all the reads. And finally, your data will be replicated, that whatever is, you're just writing to the primary data center, right? So you should be able to replicate all the data documents that you're writing it to the one data center to all your your secondary data centers that you have. So we went right in and we started with saying, with our current architecture, this is how it looks like, right? It's pretty easy, where you can see your Zookeeper talking to your Solar, and your applications are connected to your Zookeeper. So we were on a 5.x version, and the replication is only supported if you upgrade it to 6. So we jumped right in and we started to see how we can do an upgrade, a smooth upgrade. So we started doing our upgrades for the Solar Cloud for communities to be at 6.x. And then once we upgraded that, then we actually had 2 clusters set up on both the regions to try to see if we can replicate whatever is written in the documentation, right? So we created both the Solar Cloud clusters and the Zookeeper on a public subnet. And the Solar was first connected to the Zookeeper, where all the host address information the Zookeeper can talk to from both the regions to the primary data center. And then we started doing the replication between both the Solar, and it should work, right? Totally, it should work. So the problems that we ran into were, the first thing was the connection that you see from Solar to Zookeeper doesn't support SSL. So that was a big no-no from a security perspective. The second thing that I have marked as a challenge was when we started doing replication, we came to know that at that particular time, we came to know that you cannot copy the existing documents. You can only start replication from the time you start your application, from that timestamp, not any time before that. What it means to us is now you are anticipating more than an hour of an outage if you have to copy all the data, all the indexes that you have on a primary to a secondary to make the secondary data center your primary. So you have increased that time so much that we can no longer use that solution for us to be, even for us to be considering active standby. And again, the last but not the least was you have to maintain the same number of shards regardless of how many regions that you go to. So the first two were the main reasons why we didn't use the solution what Solar Cloud was providing. So the next basic thing people jump into is, hey, you can use Kafka in front of it, and you can totally do the replication, right? So you can keep the Solar, whichever version it is, and you can put Kafka on top of it, and you can do your replication. It should work magically, right? As you grow into more and more regions, you will have more and more operational overhead. So you are now talking about, if you have a problem, you have to look at Solar Cloud, Zookeeper, Kafka, and Kafka Zookeeper. And you have to keep Kafka separate just to make sure that it's dedicated to your Solar Cloud replication. It's not serving all the other purposes, right? So the challenges from that perspective were, of course, operational overhead. You are maintaining way too much once you go live. And more failure points. When you are trying to diagnose an issue, it'll take forever for you to figure out where the problem is as you go to more than 2 regions. And it's expensive. You're adding Kafka in front of Solar Cloud, right? So this is how our situation was. We already had 2 meetings, and we are back to stage 1 on what are we going to do. So within community search, we are using SQS for data sync. So what we were thinking was, we are anyways using SQS on one region. Why can't we keep Solar on each region, and we are not source of truth for that data anyways? So why don't we just rely on SQS, and SQS is going to do all the data, all the messaging to each and every Solar cluster. And in that way, you don't have to rely on Kafka, or if you guys are using Kinesis, you don't have to rely on Kinesis, right? Nothing like that, and you can just use whatever we have today. So the reason why we stick with SQS is pretty reliable, and we've been using from 2 years, the day 1 when communities actually went live. So with this, let me hand it back to Stephanie to talk about community search using SQS.
So loose coupling sets you free, as Amy mentioned earlier. This is a principle that we had in mind when we designed community search. This is a high-level diagram of the data flow when updates come in. A user come in and update their communities. Our service will send a message downstream to an SQS. Then a separate component, an indexer, will consume this message and process it. And it'll go back and tell Solar Cloud, hey, please create a new Solar document or update an existing Solar document. And for the case when a user comes in and search for a particular community, our service will issue a query to our Solar Cloud in the back end. So we mentioned that we want to keep search local in each region. So what does it look like? It's really simple. It's almost just a duplicated tech stack over to the new region. And everything you see here is fairly easy to stand up from an operation and deployment point of view. You basically deploy your service artifact. You stand up a SQS in AWS, and you have a Solar Cloud cluster. But the thing that's really missing here is you have a Solar Cloud cluster, but you don't have an index. So this is actually not a multi-region specific problem. This is the same problem when you launch a search feature after your product goes live, which is the case for communities. We actually launched the search feature about 6 months after our communities was launched. And by that time, we already have a lot of communities created on production, and we have to go back and recreate our index from scratch before we launch the search feature. So we go back and look at actually how did we do it before we jump into how do we do multi-region. Let's look at how to even create an index, even in a single region scenario. We are the source of truth. We have all the community's data. So it's fairly easy for us to just iterate through all of them and create our indexes. So in this case, we're going to create a temporary component, a re-indexing service. And we're going to stand up a temporary SQS just for this purpose. With the indexer and the way that it's loosely coupled, it actually almost required no code change in the indexer levels. The re-indexing service would just go through our entire database and iterate through each role for each community. And it'll send a message downstream to say, hey, I have just created a new community. And the indexer would tell Solar Cloud to create a new Solar document. Let's see how we can apply this very same technique in a multi-region index replication scenario. Region 1 is our live region, nothing changed. In region 2, we have not started serving any customer yet. So we're not going to deploy our user-facing community service just yet. You have the same SQS created, just like region 1, the same indexer. You have your brand new Solar Cloud cluster with an empty index. And we're going to plug in the temporary components that I just talked about, our re-indexing component and a temporary SQS, just for index creation purpose. Now remember, when you're doing this index creation, you have live updates coming in all the time in region 1. People are constantly updating the communities. So you want to keep those updates, but you cannot process them yet because you don't even have an index in region 2. we're going to use the same mechanism, our feature switch, to pause our consumption from the index update SQS so that we can hang on to those updates until we're ready to process them. And you go ahead and start processing the index creation coming in from the reindexing service. And you'll notice that in region 1, that's where all the live query and search query are still being served. So there's no user impact at this point. User wouldn't even know that you're doing this behind the scene. At some point, your reindexing will be completed. And you want to stop processing the index creation messages. There might be a few leftover messages that you have not consumed in this process, but that is actually OK because the same updates are actually coming in region 1 as well. You just haven't caught up with them yet. So let's go ahead and start processing those live updates message. Now remember, if your reindexing process is going to take a while, you can be holding on to a lot of update message coming in from your live environment. You want to make sure that your retention period on that SQS is long enough to hold on to those messages. So eventually, your indexer will catch up with the consumption of the live updates. And now you have a full and ready index in region 2, and that is also being constantly updated from live traffic. At this point, you're ready to serve live customer. So remember that even though we want to keep our search local in each region, our search result has to be consistent across the globe. That means that doesn't matter where the user is coming in from, where they make an update, the update has to be written to all the regions that are active in your system. So that's why there's a cross-region SQS write in this case. So this looks fairly simple when you have 2 regions. You're just crisscrossing to 2 regions with 2 SQS endpoints. What if you have 3 or 5? You start to get a lot of code clutter, or actually, I hope that you don't introduce any code clutter in this case. Hopefully, it's just a configuration for you. But eventually, you'll probably end up with 6 or 8 or 10 different SQS endpoints that you have to take care of. This is really starting to get messy. So we were looking for a way to clean this up a little bit and abstract this a little further. We introduced SNS on top of SQS. Now we're able to publish all our update message to a single SNS topic only. And then downstream, we can subscribe from this topic from any region and any number of regions that we want. And all of the subscription is managed by AWS console or an AWS API. There's little to no code change when you want to expand to a new region. With all the loose coupling in between our components and all the messaging mechanism, we were really able to iterate through our design and experiment with things on production very quickly. So as Swati mentioned, our Solar Cloud multi-region journey was not without challenge. We actually have to do it 3 times until we have arrived at a successful solution using SQS. And each of the experiments require us to create an entire new index, redirect a lot of read and write. And when the experiment fails, when we start noticing problem with our Solar Cloud 6 solution, we need to very quickly fall back to our existing region and our existing cluster, basically failing back to a single region solution. But we were able to do this with very, very low code change with SNS, SQS, and also the dynamic switches. Actually, most of them just require the dynamic switch operation. So these are the 2, probably the top 2 challenges that we have with communities multi-region. And this project took us almost a year to complete, and we've been multi-region on production for almost 2 months now. So before we wrap up this session, we would like to share a few more lessons learned from our overall journey. Always test. It doesn't matter what the documentation tells you. You need to always test your replication strategy. Does it work? And does it work for your use case in particular? Caching. Caching is probably one of the hardest problems in computer science after what to name your variables. If you don't want to have a multi-region solution for your caching layer, which I would recommend against, you need to make sure that when you're deploying to a new region, you need to warm up your cache, because you might be the first one to be using the shared cache layer, and you'll be starting with a completely cold cache. And after you go multi-region, usually problems don't show up right away. In fact, usually show up after about 2 weeks or 3 weeks. So please wait at least a month before you have that epic party to celebrate your success.
So before you take that leap into your multi-region journey, remember to have those questions and discussions with your team. Do you need multi-region, and do you want multi-region architecture? Do you want to deal with the complexity and the costs around it? And if so, do you understand and know how to put together those building blocks?
So make sure you are architecting your infrastructure for more than 2 regions, as you are going to reuse all the components that you're building.
Yeah, and once you have a good foundation from the building blocks and the infrastructure, as you test and experiment on production, make sure you always have a fallback strategy before you take the big leap. And thank you very much. This is it for us.
Thank you.
Thank you.